So in this short video, what we're going to do is have a little look at the formation of racemic mixtures in the reactions of aldehydes and ketones. Now this is the last section of your notes pack. So what is a racemic mixture? A racemic mixture is a mixture of equal amounts of two enantiomers. These two structures here are classed as enantiomers. They are chiral carbons, carbons with four different groups, and they are non-superimposable mirror images of one another. That's what we mean by enantiomers or optical isomers, and we've got an equal amount of each. How are they non-superimposable? So what you've got to be able to do is imagine picking up this one on the right and rotating it round, twisting it round and putting it down so that the CH3 is sticking out to the left like it is over here. So if you turn that around, but if you did that, the CN would point forwards and the OH would point back, so it wouldn't be quite the same as the one on the left. They are non-superimposable mirror images of one another. So that's what we've just been saying. Enantiomers are optical isomers. They are non-superimposable mirror images. Optical isomerism is one of the two types of stereoisomerism. Geometric or EZ isomerism is the other that we learnt about in the alkenes pack. It occurs, optical isomerism, when you've got a molecule containing a chiral carbon, a carbon with four different groups attached. So what are the properties of optical isomerism? Well, optical isomers chemically are identical, so do a chemical reaction with them. If you add sodium carbonate and it fizzes, they both contain a carboxylic acid group. You're not going to notice any difference, right? But they do differ in one way. They differ in their effect on plane polarized light. Plane polarized light is light that has been polarized into one direction. So normally light scatters in all directions. The light has been polarized so that it's only traveling in one plane, one direction. And when you pass that through the enantiomers, one of the enantiomers will rotate the light clockwise and the other anti-clockwise. You must use the word rotate. No other word is acceptable there. You can't say bend or refract or reflect. It has to be the word rotate, and it rotates the light, plane polarized light, an equal amount in opposite directions. Right. What about these racemic mixtures then? This 50-50 mixture of two enantiomers. Well, the 50-50 mixture will not rotate the light because half of the mixture is rotating the light clockwise and the other half is rotating it anti-clockwise, and the two effects cancel out. So this is really important in exam questions because sometimes the exam questions try to catch you out by saying that the product doesn't rotate light. That often leads you to think, oh, then the product can't contain a chiral centre. But you have to remember that it could contain a chiral centre but just be racemic if the way that it's formed has allowed a racemic mixture to form. So you need to be able to explain to the examiner why you're going to get this racemic mixture in the reactions of aldehydes and ketones. So the reaction of aldehydes and ketones is called nucleophilic addition. So why would we get a racemic mixture? And there's some really key points you've got to be able to explain in your exam answers. The shape around the C double bond O, that's this C here, the shape around the C double bond O, sometimes called the carbonyl carbon, is trigonal planar. It's absolutely essential that you don't say that the whole molecule is trigonal planar. This bit, this R group, is not trigonal planar. This will probably contain tetrahedral carbons, and so you can't say the molecule is trigonal planar, but the shape around the carbonyl carbon or the C double bond O carbon is trigonal planar. And because it's flat, planar, then when the nucleophile attacks it, the nucleophile could attack it from above the plane or below the plane, so on top or underneath, and that is equally likely to happen. And if it's equally likely to happen, you're going to get an equal mixture of two isomers, the two optical isomers. So let's have a look at this mechanism then. So at the top here, we've got the planar carbonyl carbon here, this trigonal planar part, and the cyanide is going to attack him from underneath. And as it does that, it attaches itself, it forms a covalent bond, so this lone pair becomes a shared pair, and all these three groups sort of push up like an umbrella turning inside out. So they're going up here, and the cyanide is coming in from underneath, and then the mechanism finishes off and we end up with this product. Now if the cyanide were to attack from on top, like in this bottom section here, then it's going to push all these three groups down, And when those three groups push down, we'll end up with this isomer. Now, if you look at these two, you can imagine there being a mirror here. You can see that they are mirror images of one another, and so they are non-superimposable mirror images. They are optical isomers. Now, if it's equally likely from above or below, you're going to get equal amounts of these two and you're going to form racemic mixtures. So each of those products is still chiral. They still have a carbon with 4 different groups, but the mixture itself will not rotate plane polarized light. So it's a chiral mixture, it's got chiral carbons, but it doesn't rotate the light because it's racemic. Not because it's not chiral, because it's racemic. It's got equal amounts. So, a couple of exam tips for you, just a few. Number one, when you're asked to name and outline the mechanism, you don't need to draw it out like I did a couple of slides back in 3 dimensions. You can just draw it flat on the paper. Don't make life difficult for yourself. Just draw it out as you normally would and call it nucleophilic addition and score those marks. That's a nice 5 marks, 4 for the mechanism and 1 for the name. Get those marks, practice that mechanism. Name the type of mixture. That's another typical exam question. So the type of mixture is just to say it's racemic. Just watch out for the number of lines in the question or the number of marks. If it's worth more than 1 mark or there's more than 1 line available, perhaps you need to say that a racemic mixture is an equal mixture of the 2 enantiomers, a 50-50 mix of the 2 enantiomers. If it asks you how it forms, this is a really common question. It's worth 3 marks. It's really common. The 3 marks are the 3 bold black parts here. The shape around the C double bond O is trigonal planar. Do not say the molecule. The shape around the C double bond O or carbonyl carbon is trigonal planar. There's an equal chance of attack from above or below that plane, so the nucleophile can attack from either side of the plane, and that leads to an equal mix of 2 enantiomers. That's called a racemic mixture. If it asks you to then draw out the products and show how they're related, it's really important that when you draw those out that you draw in 3 dimensions, because you need to be able to show that they are non-superimposable mirror images of one another. And if you don't draw in 3 dimensions, then they are superimposable. So a non-superimposable mirror image of each other, make sure you draw them as mirror images and that you have one here, tetrahedral carbon, and then the mirror image version on the other side.